As a show of hands, how many people are from academia? And industry? Mostly industry. So that's good. Because what I wanted to kind of talk about is, as you are looking at different architectures for building agents, so let's imagine that multi-agent is going to be the common design pattern for enterprise applications maybe in a year or two. It's still not there, right? And a year or two is actually being very, very optimistic. So this is your new workload, a swarm of agents. Imagine a new enterprise with 100 agents running alongside, human workers. Basically, my swarm of digital minions, right? So now the question is, where will these agents run? Most people think today it runs in the cloud because that's where we are running all these agents today. There are these platforms, and these mega companies like OpenAI, Anthropic, Google, they're just running everything in the cloud. But that's today. But what we see in the enterprise is that it's going to run anywhere and everywhere, right from your shop floor to a battleship, submarine, all the way to your distribution center in case of retail. So the question is, how will you actually build these agents? How are you going to choose the models? How are you going to choose the systems and the entire stack? And now, for an enterprise IT, this is a huge problem because now you've created multiple stacks, multiple systems that they have to manage, and the InfoSec, the security officer, is also challenged because you have to then define the security policies of everything. For people who work in the industry, you know how tightly controlled these systems often need to be because the data has governance rules, especially for certain workloads like in banks, healthcare. Data cannot often leave certain guarded walls. So we believe that one needs to have consistent technical architecture for running these agents. And so the question is, how do we design the next generation enterprise AI systems, not AI systems? Because AI systems in the research community, in the open source community, are sprouting like mushrooms, Cambrian explosion. Of course, there'll be consolidation. So in order to design systems, you go back to distributed systems, right? You go back to the basics of hardcore system theory, and think about CAP theorem, where you see that only two of the three properties of a distributed system can be true, between consistency, availability, and partition. Now the question is there something like this for a multi-agent system? Because why? Because a multi-agent system is also a distributed system. So that's the kind of question that we have started asking within our team in Nutanix AI. And then one of our engineers, I don't know if he's here, Janan, so one of our engineers came up with a conjecture. It was a claim that maybe there is a CAP theorem, indeed, for designing distributed agentic system, and we called it the bar theorem. And because it was a fun talk, we actually said, let's go and have, most of us go to a bar and decide on a napkin what we need to do. So we called it a bar theorem, which is essentially the three dimensions are budget. So how do I respond? How does an agent or an LLM, even an LLM, respond within a particular latency and with a particular compute budget? So that's your budget and authenticity. So how do I know that the retrieval? So let's imagine a compound AI system, which the term was founded over here in Berkeley. A compound AI system is retrieving information. How do you know it's not hallucinating? What's the accuracy level? And then reasoning. So in reasoning, we are looking for human-like chains of thought that are logical. So now, if these are the three dimensions, we claim that any Gen AI system or multi-agentic system can prioritize at most two of the three aspects. And this, obviously, it's a very tall claim. So from within our team, a bunch of us got together to kind of, as computer scientists, when you want to prove a tall claim, you prove with you start with smaller claims. And so we have some initial results that we are soon going to be in ArchiveX, where we've actually shown that for certain scenarios, this is actually true, using formal mechanisms. So, but over here, like, let's look at the bar theorem in real life, right? So if you think about enterprise AI, most of the common use cases, 90% plus use cases, basically talk to my data. Talk to my data, talk to my code, talk to my data warehouse, talk to my time series. And that's basically, you want cheap retrieval, you want less hallucination, because you don't want data retrieval or a query system or a RAG tool give you false results. Then you want to take an action, you want auditable trails, and you want some kind of reasoning, mild reasoning with some small LLMs, and you want it to be cheap too, right? So there are these RPA agents and a bunch of other agents where you can build pretty much with open source small models today. But they may not be very highly accurate for retrieval. But then there are these large compound AI systems that we all know about, deep research agents, coding assistants, and very complex video generation, which is pretty good. But the price that we pay today, somebody's subsidizing it today. When we all have to pay for the ChatGPT and the Anthropics of the world, and there has to be a P&L budget associated, I think the cost will be much more than it is today. Unless this community can design very, very cost-effective solutions to bring down the cost by 2 orders of magnitude, it's going to be hard. So our claim is that this bar theorem is going to be true in real life for a while. Now, if you think about an enterprise, look at a bank, a hospital. We all have to go to a hospital. We have to go to a retail store. When you want to design agents that run all the way from a retail store to a packing distribution center to the headquarters, data centers, and in the cloud, if you look at every data scientist today, they all want 4 to 5 LLMs to build an agent. It's not just one LLM, right? You need an embedding endpoint, you need an inference endpoint, you need re-rankers and guardrails and so on and so forth. So if you look at an entire cost to the enterprise, the TCO is astronomical. And most of these data scientists today, including in my own team, a bunch of them are here, everybody loves to run VLLM, again from Berkeley, or pick your favorite inference endpoint in a container and just run it and not have to deal with any other thing. Like, I just run it on my laptop or running it on Olama. So that is what's happening today. But what the IT departments of enterprise is petrified and paranoid, because it just leads to a huge problem with security. It's complex to manage, the security risks, it's just expensive. So our strategy for at least, with the budget part of it and complexity part of it, is to kind of shrink everything down into shared enterprise grade endpoint management and consistent architectures, starting with Kubernetes. We've internally inside the company, we've standardized on vector databases using open source. Basically, everything is open source, using Postgres, PG Vector. So we have an entire stack that we use to run multiple agents, and the agents can come from with any kind of tool chain, and you can have any kind of communication protocol. That's, for us, the technical community will figure it out. For me, the first thing is how do I manage the costs? How do I make it easy to deploy? I partner with my CIO to make sure we can do this inside the company in a simple, secure, and efficient manner. I'll end the talk with a couple of non-technical stuff, which is very important as you design systems. There are three dimensions of AI, at least in Nutanix and in most enterprise companies that I talk to, are people, tech, and process. Of course, this conference and most conferences and the entire valley is focused on the tech, which is the right thing to do. But when we look at deploying these agents in actually enterprise companies, banks, hospitals, companies like Nutanix, retail stores, people become a huge issue dimension in the sense that we need to upskill existing employees to learn AI, to understand how to even deploy, even operate these agents. Because at the end of the day, autonomous agents are still going to be a thing in the future, right? Thing of the future. It's not happening anytime soon. So, and the other thing is processes. Today's enterprise already have fixed processes. We all love to, in this conference, want to talk about multi-agent systems, talking to each other using some protocol, but that's not how they will be deployed today. There has to be a change in processes. How do you show the ROI? Think in terms of, if you spend $1 million building and deploying agents, are you going to get $5 million worth of ROI? That's still an open question. And the other thing is that coming to an enterprise is not just engineering, right? A lot of people are very concerned. So you have the AI team that wants to do the cool things, the right tech, and then supposedly they are being slowed down, but it's not slowed down because in a regulated industry, the IT comes in and says, you cannot run this wherever you want. You can't just run a VLLM container where you want. And then there's a legal team that says, how are you going to run this brand new model just popped up in a leaderboard, because I don't even know whether you can even use this. We don't know what the data provenance of that model is. So there are, again, three dimensions in an organization, and these three teams. So I'm usually in meetings with these three stakeholders, IT, the legal team, and the AI team, to figure out how do we change the processes that I talked about in this. And for each of this, is there a theorem that we can prove or a conjecture that we can come up with? How do we keep everyone happy? How do we show ROI in the enterprise while doing the right technology over here? Because we are all technical folks here. So anyway, the key takeaways is that multi-agent systems are going to happen. They're going to happen slowly, as you can see. 4 to 5 LLMs per agent, 100 agents. Think about this, and LLMs are becoming small. They're getting better at reasoning, but you need to run these agents close to where you want to do your business. Maybe in the bank, maybe in case of military, somewhere else, right? In the field, battlefield. And you need to run agents close, and then you need to design these agents. They are distributed systems, so think about what are the real technical barriers. Where is the sweet spot for designing these agents? And manage your infrastructure sprawl. Don't think of that. Even as technical folks, think about when you're building something, how is this going to be managed, deployed, used? So I think with that, prioritize not just tech, but people and processes when you're thinking in terms of computer science. But I feel CS is a wide enough field. It's liberal arts today. You can actually apply computer science to all the three dimensions. And with that, thank you.